My voice is audible?
Yes, sir.
Okay, so we were solving the numerical. So I will quickly draw the diagram. So the beam was given to us. So this is the beam. And it is a simply supported beam. So I will draw the simple supports. So the simple support is provided at point A as well as at point B, RA and RB. And the load which is given to us is this type of load, trapezoidal load. Which is acting vertically downwards. Okay, so this type of loading is given to us. Okay, so now what we have done in this, we have dropped one perpendicular from this point up to here, and we divided this load into UDL and UVL. So if I write here the intensity, it is 800 Newton per meter at this point, and this total intensity is 1600. Okay, 1600 Newton per meter total intensity. If this is 800, then we have calculated this remaining is also 800 Newton per meter as it is rectangle, and this intensity, this much is also 800 Newton per meter. And after that, we have calculated the value of RB, I think so. RB and RE. Do we have calculated the value of RB?
Yes, sir.
Okay. What was the value of RB?
3,332 Newton.
3,332 Newton. This is the value of RB, and this span is given to us as a 5 meter. Now we have applied taking the moment at point A. We took the moment at point A, and after that we have calculated this value RB. Now we know the value RB. Now after the calculation of RB, apply summation Fy equal to 0. Okay, so that you will get the value of RA. So now if I apply summation Fy equal to 0, the upward forces are positive, downward forces are negative. Then what do I get? RA is moving upward, so plus RA. Then this load, this is the UDL, that is the rectangular load. So this is moving downward, so it is minus. And now we need to take this UDL, we have to convert it into the point load or rectangular load into the point load. So intensity is 800, so this intensity is 800, that is one of the side, and this length is 5 meter. So it will be 800 into 5. So this is nothing but point load. 800 into 5 is the point load, which is vertical. Then similarly, we need to consider about this triangle also. So if you see this triangle, again the load is moving, acting vertically downward through its CG. So ह्याचा जर CG मी बघितला तर इथं कुठेतरी असेल, आणि ट्रायंगलचा CG इथं कुठेतरी असेल from right angle for the triangle. Okay. So now this load is acting through the CG of the triangle, point load, and acting vertically downwards. But the area of the diagram or area of the triangle gives you the intensity of the load, that is the point load. So it is minus, it is half into 5 is the base of the triangle and 800 is the height. Okay. Then RB is moving upward, so plus RB, which is equal to 0. RB is moving upward, so plus RB, which is equal to 0. Now put the value of RB and calculate the value of RA. Therefore RA is equal to काय होईल तिकडे गेल्यावरती प्लस होईल 800 into 5 plus half into 5 into 800 minus RB is 3332. Therefore RA is equal to, what is the answer? Let me know the answer.
2668 Newton.
2668 Newton. Okay. So others, please do check the answers. So this is how we have solved this numerical. Okay. So if you don't, if you are not having any doubt, then we will take the next numerical. If yes, then you can ask me. Anybody is having any doubt in this? So shall we take the next example then?
Yes, sir.
Okay.
Yes, sir.
Okay.
सर
हा बोला.
सर तुम्ही होमवर्क साठी एक आणखीन एक एक्झाम्पल दिलं होतं त्याच्यामध्ये यू विल यूज करून एक्झाम्पल आपल्याला सोडवायचं होतं.
बरं मग सोडवलंय का?
हो सर सोडवले फक्त आन्सर चेक करायचे तेच त्यासाठी विचारायचं होतं.
हाच प्रॉब्लेम दिला होता का दुसरा दिला होता?
दुसरा होता सर कोणता?
बरं तुम्ही मला हे करा की प्रॉब्लेम माझ्या लक्षात नाही तुम्हाला नेमकं होमवर्कला कुठला दिला होता मी.
ओके सर.
तुम्ही मला काय करा प्रॉब्लेम जो आहे ना तो मला व्हॉट्सअप वरती पाठवून द्या मी नेक्स्ट लेक्चर मध्ये त्याचा आन्सर सांगतो तुम्हाला.
हा सर ठीक आहे.
ओके. So now next numerical. Calculate the reactions of the beam shown below. Now we need to calculate the reactions of the beam which is given below. So the beam is, I will draw it. So this is the beam. Then it is having support reactions at these points. This is your point where you have first support and this is the point where you are having second support. So I will name these points as point A and point B. So reaction at this point is RA and reaction at this point is RB. Now they have further given us the loading. In the load, here is one point load acting at this end, another point load acting at this end, and here somewhere one more point load is there. And the values are 800. This is 800 Newton. This is 2000 Newton. And again 1000 Newton. And the distances, now I will give the distances. So distances are, this distance it is 3 meter. This total it is 5 meter. Then again this one which is remaining it is 2 meters. So the distances are, this is 3 meter, this total distance is 8 meter, and this is again 2 meter. One more distance is given, this distance. This distance is also given, and it is how much? 5 meter. Okay, so this is 5 meter. So this is the given numerical. Now we have to solve this. Okay, the same way we will do. Now see here, at this point a reaction RA is there, at this point B reaction RB is there, and only 3 point loads are given. This is called as overhang beam. Okay, this type of structure, it is called as overhang beam. In this you can see your supports are not at the ends. The supports are placed intermediately, and at the ends you can see this portion there is no support. Here also there is no support. So this portion is known as a overhang portion. This is called as overhang portion. This is also overhang portion. Okay, so these types of beams are called as overhang beams. If the beams are having two simple supports at the ends, then those are called as simply supported beams. And the beams which are having overhang portion on one of the side, असं काही कंपल्शन नाही की दोन्हीकडेच ओव्हरहँग पाहिजे, दोन्हीपैकी एका साइडला जरी ओव्हरहँग पोर्शन असला असा तर त्याला आपण म्हणतो ओव्हरहँग बीम. देन वी कॉल दॅट बीम ॲज अ ओव्हरहँग बीम. सो नाउ I will apply the equation. So summation m. So where we should take the moment. So suppose now this is point C, A, this is D, and last point is E. Now you tell me at which point we should take the moment and why. Now I want to take the moment. We want to take the moment. Okay. So at which point we should take the moment?
We can take at either point A or B.
Okay, so we can take the moment either at point A or at point B. Why? What is the reason?
So if we take at point A, then we will get the RB, or if we will take at point B, then we can get RA.
RA, correct. So see, either we should take the moment at point A or at point B. We can take the moment at point C also, but it is not useful for us. See, if I take the moment at point C, if I take the moment at point D, at any point you can take the moment. But if I apply the equation of moment for this point C, then in that equation you can see RA will be also there. RA will also get some moment about this point, and RB also will get some moment about this point. So in that equation we will get two unknowns, RA and RB both. Okay, RA and RB both, two unknowns we will get. So it is none of our use. Why to take the moment and get one equation which is having two unknowns? Again we will apply some different equations, summation Fy, and again two equations, two unknowns, and then we have to solve the numerical. So instead of going in such a long way, you should always see where the supports are given. Now, first of all, if I want to calculate the value of RB, I can directly take the moment at point A, because RA will become 0. So one of the unknown will get eliminated. Okay, in this way you have to think while taking the moments. Okay, so here I will take moment at point A is equal to 0. Clockwise moments are positive, anti-clockwise moments are negative. Problem is very simple. So here you can see at point A we are taking the moment, so RA will become 0. This 800 Newton distance is 3 meter. It will rotate in anti-clockwise direction. This will rotate in anti-clockwise direction. So it is minus 800 into 3, minus 800 into 3, RA is 0. Then this 2000, it is rotating in clockwise direction. You can see the direction, and the distance is 5 meter. So it is 2000 into 5 plus 2000 into 5 plus, no, if RB is there, then it is not plus. Now see here, this RB about this point A, the distance of A and B point, it is 8 meters. So the distance of RB is 8 meter, and it will rotate in anti-clockwise direction. So minus 8 RB. Then this last load 1000 Newton, it will rotate in clockwise direction to point A. This is the clockwise direction, and the distance is, this is 8 plus this is 2. So the total distance is 10. So it will be plus 1000 into 10 is equal to 0. Now send the RB to that side and solve this equation. So we will get the value of RB. This will become 2400 plus this will become 10,000 minus 8 RB plus 1000 into 10, again 10,000 is equal to 0. So if you send 8 RB to that side, then you will get 8 RB is equal to 17600. Therefore RB is equal to, बरोबर आहे ना, 10 20 20 मधनं 2400 गेले,
2200.
2200. Okay, we got the positive answer, so our assumed direction is correct. RB is moving upward. Now once you get one of the unknown, the calculation of other unknown is very easy. Now I will apply summation Fy equal to 0. So here now I will apply summation Fy equal to 0. Upward forces are positive, downward forces are negative. So if you apply summation Fy equal to 0, what you will get? You will get minus 800 plus Ra, then minus 2000 plus Rb minus 1000. All this is equal to 0. So therefore, now put the value of Rb in the equation, you will get the value of Ra. Put this value of Rb in the equation.
$1,600.
1600 Newton. Okay. 1600 Newton. So these are the answers, Ra and Rb. Problem is there in front of you. Any doubt? Anybody is having any doubt in this?
मायनस 2400
हा, हे मायनस 2400 बरोबर, करेक्ट. करताना कॅल्क्युलेशन बरोबर आहे ना पण पुढचं?
minus 1600.
मायनस
1600.
Ra. How it is minus? See here, Ra here it is plus. This is minus, this is minus, this is minus. So all this minus, if you transfer to that side, it will become plus. And from that you have to minus this Rb. Here 2000 and 1000 म्हणजे 3000 इथंच झाले. And here 3800. So 3800 will become plus if that gone to that side. And त्याच्यातलं तुम्हाला 2200 मायनस करायचे ना.
Yes, sir.
Then Ra is plus. No, Ra's answer is. This answer is correct. See here. This is minus 800 minus 2000 minus 2800 minus 1000. So it is minus 3800 plus Ra plus 2200 is equal to 0. Okay. So it will become minus 1600 plus Ra is equal to 0. Therefore, Ra is equal to, now this is minus, if you send it to that side, it will become plus. Clear?
Sir.
Okay. So next problem. Find the support reactions. Find the support reactions of beam given below. The beam is, again overhang beam is given. Here is one support, support. So this is support at point A. This is the support at point B. Now loading here at this point, a point load is there, and throughout the beam UDL is acting. So UDL is given. This is the UDL. This is 2 kilonewton per meter. This is 2 kilonewton. This is 2 kilonewton. Here it is. This is point A. This is B. This is point C. Reaction RB. Reaction RA. The distances are 4 meter and 2 meter. So the distances are this much is 4 meter. And from this point it is 2 meter. So this is 4 meter and this is 2 meter. Okay, so this is the given diagram. Now you tell me how to take it, solve it. So here again, here you can see at point A reaction RA is there, at point B reaction RB is there. So either we should take the moment at point A or moment at point D. So we will go with moment at point A. So now if I take summation M about A is equal to 0, then the clockwise moments are positive, anti-clockwise moments are negative. So here, first of all, you can see RA is passing through point A, its moment is 0. Okay. Now you tell me how to convert this UDL into the point load and what is the distance. I will wait here. You tell me how to convert the UDL into the point load and what is its perpendicular distance.
4 into 2.
4 into 2.
6 into 2.
6 into 2, correct. So this UDL is, see, बघा आता तुम्ही सांगितलं 4 into 2 आणि नंतर सांगितलं 6 into 2. आता बघा मी काय सांगतो ते नीट ऐका, मराठीत सांगतोय. ह्या UDL ची जर तुम्ही इंटेन्सिटी बघितली तर A पॉइंट पासून C पॉइंट पर्यंत कॉन्स्टंट आहे, सेम आहे, म्हणजे सेम UDL इथं गेलेला आहे. त्याच्यामुळं ह्याचा स्पॅन झाला 6 मीटर. जर ह्याच्याऐवजी न्यूमरिकल मध्ये तुम्हाला समजा असं दिलं असतं की A to B वरती 2 मीटरचा UDL आहे आणि इथला UDL समजा वेगळा दिला असता 3 किलोन्यूटन पर मीटर असा दिला असता, तुम्हाला काय करावं लागलं असतं, A to B मधला UDL किती आहे 2 किलोन्यूटन, B to C मधला किती आहे 3 किलोन्यूटन, मग ह्याचं सेपरेट घ्यावं लागलं असतं, ह्याचं वेगळं घ्यावं लागलं असतं मुवमेंट घेताना. Okay, you need to convert this UDL separately and this UDL from B to C separately. If the intensities of the UDLs are different, means two different loads are given. But right now, in our case, in this numerical, this is not given. Okay, so our UDL is same from A point to C point. So now if I convert this UDL into the point load, then it will be 2 into 6. Now this is the conversion of UDL into the point load. Now tell me what is the perpendicular distance?
3 meter.
3 meter, correct. So now you can see the total span is 6 meter. So when you multiply this 2 by 6, you will get a point load and that point load will act at the center of this UDL. So UDL ची लेंथ किती आहे 6 मीटर, त्याचा सेंटर म्हणजे कितीला येणार आहे तो 3 मीटरला. So from this point A, it is acting at a distance of 3 meter and it is moving down. Okay, this load is moving down. So you can rotate it like this. Moving down म्हणजे खाली ओढा त्याला आणि रोटेट करा A पॉइंटला. So it is rotating clockwise direction. Next is this RB. So minus RB is moving upward. RB is moving upward, so it will rotate in anti-clockwise direction. The distance of RB is 4 meter. Minus 4 RB, correct. Then next is this 2 kilonewton force. हे आता ऑलरेडी आपण कन्सिडर केलेला आहे या 6 मीटर मध्ये, हे झालेलं आहे, इथंच कन्सिडर केलेलं आहे आपण. So now this load 2 kilonewton. So the distance is 4 plus 2, again 6 meter is the distance. So it will be 2 into 6. Now it is moving downwards, so this is plus, it will rotate in clockwise direction, which is equal to 0. So therefore RB is equal to
-12.
RB minus 12. Minus the answer.
Yes, sir.
कसं आहे ते मायनस? एक मिनिट, हे बघा काय तुम्ही असं सिंपल मॅथ्सला असं केल्यावरती कसं व्हायचं? हे बघा, हे 2 × 6 × 3, आय विल कीप दिस ब्रॅकेट ॲज इट इज, प्लस दिस 2 × 6 हा आपण असंच ठेवला, अजून मी कॅल्क्युलेशन करत नाही. हे 4RB मायनस आहे इकडं, तिकडे गेल्यावरती काय होईल? प्लस 4RB होईल का नाही? मग इथं मायनस साईनच कुठं राहत नाही, तर तुमचा आन्सर मायनस येतेच कसं? ही टर्म प्लस आहे, ही टर्म प्लस आहे, फक्त 4RB मायनस आहे ना इथं. मायनस 4RB जर मी त्या साईडला ट्रान्सफर केलं, इफ आय ट्रान्सफर इट टू राईट हँड साइड, इट विल बिकम प्लस 4. 4RB मायनस साइन काय होईल? प्लस होईल ना. What is the answer then?
12.
So RB is equal to 12 kilonewton. And our assumed direction is correct as we have got the plus answer. Okay. So now apply summation Fy equal to 0. Upward is plus, downward is minus. So now RA, which is moving upward, plus, then this UDL, it is minus. Okay, because it is moving down. So intensity of the UDL is 2 and the span of UDL is 6. Okay, so 2 × 6, it is conversion of UDL into the point load. This is not the moment, this is the conversion of UDL into the point load, plus RB moving upward, and then minus 2 moving downward, which is equal to 0. So RA, it will be as it is, minus 6 × 2, 12, plus RB plus 12, then minus 2 is equal to 0. Therefore, RA is equal to this plus 12 minus 12 will get cancelled. Minus 2, if you transfer to that side, it will become plus 2. These are the final answers. Okay. समजलं का?
Yes, sir.
So now we will take the next numerical. Find support reactions. Find support reactions of the frame shown below. Now I will draw the diagram. You also draw it with me. So this type of frame is given. Okay, so this type of frame is given. Now the supports are given to the frame at this point here and here. So the supports are this type of supports which I have shown in the diagram. Okay. Here the inclined roller is given. So first of all, I will draw the inclined surface. This is the inclined surface, and the inclination with horizontal, this inclination, it is given as 20 degree. This inclination is 20 degree, and here we will draw the roller. and these are the wheels of the roller. This is the roller support. Okay. So now the loading is given. So I will draw the loads. So here at this point, the force is given, which is of 100 Newton, and it is inclined at an angle of 30 degrees. So this angle with horizontal, it is given as 30 degrees. Then at this point over here, there is again one more load. Here the load is given like this. This load is of 70 Newton. 70 Newton, and its angle, this angle is given. It is 45 degree. 45 degree. Then here at this point, a moment is acting. A moment in clockwise direction is acting. It is 30 kilonewton meter. 30 kilonewton meter. Then here UDL is given up to certain span. This UDL is UDL is 250 sorry, here it is not kilonewton meter, it is Newton meter. This is also 250 Newton meter, Newton per meter. And here at this point, one more moment is given. It is again clockwise, and this moment is of 50 Newton meter. So now I will name the points. Here this point is called as point A. This point is called as point B. And now I will give you the distances. So the distances are, this distance up to this moment, it is 60 centimeter. This is 60 centimeter up to this point here. Then not up to that point. This total distance they have given 60 centimeter from this point up to the start of UDL. Up to the start of UDL, up to this point. This total distance they have given to us as 60 centimeter. Then the span of UDL is also 60 centimeter. This span, this is also 60 centimeter. And further, from here up to the point B, up to the point B, it is also 60 centimeter. For vertical height, so now if this load is given over here now, so if I take it like this, then the vertical distances are, see, this vertical distance from this point to this point, it is 40 centimeter. I will show it here. This is 40 centimeter, and again from here to here it is again 40 centimeter. Okay, I will just make sure that everything is written. Okay, this is the given numerical, and we need to calculate the reactions at point A and B, support reactions. Okay, so this is the given numerical. Now we have to solve this problem. So after seeing the diagram, one thing you should do, if such a type of frame and things are given to you, one thing you should do, that is, first of all, you should draw the line diagram of this. So if I draw the line diagram of this, see, for this vertical, I will show it by just a single line. This is the line diagram, central line diagram. I'm taking the center line of this. Okay, I am taking the center line of this, like this center line. So this is the vertical line, vertical, and then here it is, this horizontal part of the frame. I have to take, okay, I will take it somewhere down. I will take this as, so that we will get some space. So here now load is given at this point, a load is given in this way. This load is of 100 Newton, 100 Newton, and this is the horizontal line. If you draw the horizontal line, the angle with horizontal here, it is given as 30 degree. Then again next load, it is given somewhere at this point, at middle, okay, somewhere here. The intensity of this, it is 70 Newton, and this angle is given with vertical, it is 45 degree. Now here comes point A. This is our point A. So at this point now you can see this is the hinge support. Okay, this support is the hinge support. So how many reactions are there for hinge support?
2 reaction.
2 reactions are there. So one reaction is vertical and second reaction is horizontal. So these are the 2 reactions at hinge support. So I will call this as VA and I will call this reaction as HA. Okay, 2 reactions. If you show it here also, you can show it like this. This is the reaction VA. Here is the reaction HA. And what about the reaction RB? It will be perpendicular to the surface on which the roller rests. So this is the surface. So your RB will be like this. This is the reaction RB. Okay. This is your reaction RB. So here also, if I show this, this is my reaction RB. This is the reaction RB at point B. Okay, this angle is 90 degree always. So I have already told you that if the angle between these two lines is 20 degree, here is 90 degree angle between this surface and RB. Now if I take a vertical line from here, this vertical line, so this vertical line will make the angle of 90 degree with this horizontal. Okay, so if this angle is 20 degree, this angle will be also 20 degree. So here I can write this angle with vertical of RB, it is 20 degree. How does it come? Angle between the lines is angle between their normals or tangents. This is the theorem. Angle between the lines is angle between their tangents or normals. Now moving further, I will draw over here one moment. So here the moment is acting at this point, and this moment is 30 Newton meter. Here is the UDL is given, and this UDL is of 250 Newton per meter. Newton per meter. Okay, and here again the moment is given, it is 50 Newton meter. Now what we will do here, you can see the unit is given for length is meter. Okay, meter use केलेले आहे loading मध्ये, but the distances are given in centimeter, so we will take it in the meter. So if we take that into the meters, then see this distance, how much it is? Up to this point it is 40 centimeter, means 0.4 meter. Okay. So again from this point up to HA here, again up to here, this is the distance. Okay, so this is also 40 centimeter, means 0.4, 0.4 meter. Now the distances which are given below, So from this point up to the start of UDL here, okay, up to this point here, the distance is 60 centimeters, so 0.6 meter. Again, from the start of the UDL to the end of the UDL, start of the UDL to the end of the UDL, up to here, up to this point, the distance is again 60 centimeters, so 0.6 meter. And lastly, again from this point up to RB, this total distance, it is again given as 0.6 meter. 0.6 meter. So this is our given diagram. This is the line diagram of the given frame. काही विचारायचं का लाईन डायग्राम मध्ये ड्रॉ केलेलं का समजलंय काय केलंय ते फक्त तिथली डायग्राम इथं सिंगल लाईन मध्ये आपण रिप्रेझेंट केलेली आहे. We have represented our diagram in the single line. Is there any doubt in this line diagram? Yes, no?
No, sir.
Okay. So now we will start to solve this numerical. This is given numerical to us. First, we will see that this 70 Newton is inclined, 100 Newton is inclined, RB is also inclined. So we have to resolve all this. So we will start from the RB. So here, this is the point of application. So one component, vertical component of RB. This is the vertical component of RB. And this is the horizontal component of RB. So if this angle is 20 degree, then this will be RB cos 20. This is RB sin 20. Okay, RB cos 20, RB sin 20. Then if you resolve here this force, one component is parallel to X, another is parallel to Y. So this will become 100 cos 30. And this is 100 sin 30. Okay. Again, if you resolve this force, so here you will get one component, this is 70, and the another component is along this line. Here you will get another component, and now this angle is 45 degree. So this will become 70 cos 45, and this is 70 sin 45. So this is the resolution of the force. This is the resolution of the force. Now we will consider the components of the forces for the further calculation. We will consider the components of the forces. So first I will take summation M about A is equal to 0. Clockwise moments are positive, anti-clockwise moments are negative. So when I say that, then you can see over here now closely. Now this is my point A, where I am taking the moment. So HA is passing through point A, moment 0. VA is passing through point A, moment 0. This RB sin 20. If you extend the line of action, this RB sin 20, its moment is also 0. Correct. Then when you go to the upward side, you can see this 70 cos 45. This 70 cos 45, if you extend the line of action, it will also pass through point A. So its moment is also 0. Then when you move to 100 Newton, this 100 sin 30, this force, if you extend the line of action of this 100 sin 30, it will also pass through point A. So its moment is also 0. Okay. So what is remaining, that we will take in the calculation. So first of all, we will start from this 100 cos 30. 100 cos 30. Okay. So here it is 100 cos 30 into what is the distance of 100 cos 30? See, force is here and point is here. So this much is the distance. Okay, या point पासून या force से एवढं distance आहे. ये distance किती आहे? What is the distance? This much is 0.4. This is also 0.4. So total is 0.8. So from this point, the distance of this force is 0.8. So you need to multiply this by 0.8. Now again, see, this force is moving towards right. Now rotate this force about point A. Rotate it about point A. It will rotate in clockwise direction. So it is plus plus. Next force is 70 sine 45, this force at this level. Okay, so this 70 sine 45 is at a distance of this. This is the distance 0.4 from point A, and it will rotate. It is moving towards left, so it will rotate about this direction. So this is the direction of rotation. It is anti-clockwise. It is anti-clockwise. So this will be minus 70 sine 45 into 0.4. After that, now come to this point over here. This is not a force. Listen me carefully. This is not a force. This is the applied moment. So here they have directly given you the moment. There is no need to multiply it by the distance. Why? Because this is not the force. This is not a point load. This is not a UDL. This is not a UVL. This is the moment which is directly acting on the beam. Okay, so and in the equation M only we will consider the moment. In the equation of moment we will consider the moment, as it is not a force, it is a moment. So moment is 30 Newton meter. Now you see the direction of rotation. It is rotating in which direction? This is the arrow, so it will rotating in clockwise direction. Clockwise direction. So simply what I will do, it is in clockwise direction, so clockwise means plus. Clockwise means plus. So I will write here plus 30. Plus 30, because this is the moment, this is not a force, so there is no need to multiply the moment by the distance. Next, if you move further, this is the UDL. What is the UDL? The intensity is 250 and the span is 0.6. So first of all, convert this UDL into the point load. So if I convert this, it will be 250 into 0.6 into what is the distance? So the distance will be, if you see, so if you convert this UDL into the point load, that point load will act at the center of this 0.6. That point load will act at the center of this 0.6. So if it is acting at the center over here, then the distance from this end will be, if this total is 0.6, then half of it is 0.3. 0.3 and 0.6. So from point A, the distance will be 0.9. Distance will be 0.9. Okay, ज्यांना समजत नाही त्यांनी बघा हे काय होईल, 250 into 0.6 केलं की मला हा UDL काय होईल, पॉइंट लोड मध्ये कन्वर्ट होईल. आणि तो जो आलेला पॉइंट लोड आहे, तो आलेला पॉइंट लोड कुठे ऍक्ट होणार आहे, तर ह्याच्या सेंटरला, इथे ऍक्ट होईल पॉइंट लोड. ओके, आणि जर सेंटरला ऍक्ट झाला तर हे डिस्टन्स किती राहणार आहे, हे जर 0.6 असेल तर हे किती होईल, 0.3. Okay, so if it is 0.3, then from point A, the distance of the force is 0.6 plus 0.3, it is 0.9. And it is moving downwards. So if you rotate it about point A, then the rotation is clockwise rotation. Then the rotation is clockwise rotation. So this is plus. This is plus. Okay. Then next is this moment. Now same concept as we are applied for this moment, same concept will be applied over here also. This is the moment which is rotating in the clockwise direction. So plus, clockwise ऐवजी anti clockwise दिली असती तर minus घेतलं असतं. So plus, so it is plus 50. Then next is this RB sin 20 is already 0. So this RB cos 20, the distance of RB cos 20 is 0.6 plus 0.6 plus 0.6. It is 1.8, and it is moving upward, so it will rotate in anti-clockwise direction. So minus 1.8 RB cos 20 is equal to 0. Is equal to 0. Now solve this. We will finish this problem and then we will end the lecture. Okay, even if it is extended by 5-10 minutes, then also be in the lecture. So if you do the calculation fastly, it will end up fastly. So first bracket, 100 cos 30 into 0.8. किती येते?
69.28.
69.28. Okay. Minus 70 sin 45 into 0.4.
19.79.
19.79 plus 30. Plus next bracket
135.
135. Okay. Plus 50 as it is. Minus. So this is minus 1.8 RB cos 20. If I send it to that side, it will become plus 1.8 RB cos 20. So this calculation, which is on left hand side, what is the answer? $69.28 minus हे जे काय आहे ते करा की लेफ्ट साइड से किती येत आहे? हम्म
264.49.
264.49. All of you please check the answers. Okay.
Yes, sir, it's correct.
Correct.
किती आलं?
It's all, sir.
So which is equal to this 1.8 RB cos 20. Okay, so keep this RB over here. So divide it by 1.8 first. So 264.49 divided by 1.8 किती येते? काय रे? What is the answer?
146.9.
146.9 is equal to what? RB cos 20. Now again divide it by cos 20. So therefore RB is equal to 146.9 divided by cos 20 करा था.
One 156.52.
So 156.5 Newton. This is the RB. Okay. This is the RB. Now apply summation Fy equal to 0. Apply summation Fy equal to 0. Clockwise forces are plus. Upward forces are plus, downward are minus. Then here in this diagram you can see which are the forces which come into Fy. So 100 sin 30 positive, 70 cos 45 upward positive, Va is moving upward positive. Then this is not the force, 30 Newton meter is not the force, we will not consider. Then this 250 into 0.6 which is moving down, so negative. This is not a force, so we will not consider. And plus RB cos 20. Plus RB cos 20. So I will write here. Here. So it is VA moving upward plus RB cos 20 vertical component at reaction B minus 250 into 0.6 is the UDL. Okay. Plus 100 sin 30 is the vertical load, vertical component of 100 Newton, plus 70 cos 45 is equal to 0. Now put the value of RB, so you will get the value of VA. Therefore, VA plus 156.5, this is the value. You put the value and you do the calculation. Let me know the final value. VA. So after solving this, what is the value of VA? It is minus 96.55 Newton. Okay. So बघा चेक करा आन्सर देत येते का. Please confirm this answer.
Yes, sir. Minus 96.55.
Okay, so this is the answer. Now we are getting the minus answer. So we are getting the minus answer, but we have assumed that VA is moving upward. Okay, upward we have shown, but we got the answer in minus, so we can say that VA is moving down. VA is not moving upward, VA is moving downward. Okay, so VA is moving downward. So now, so that we can change the direction over here. Now VA is our not upward, VA is downward. So here I will draw the diagram of VA like this. Sorry. This is VA. Okay, here also. VA is acting like this, downward. Next, we can calculate HA now. So to calculate HA, apply summation Fx equal to 0. Forces towards right are positive, forces towards left are negative. So now here we can see on this numerical, HA, we have assumed that HA is moving towards right, so this is positive. Next is this will not come, this is not there, this is not there, this is this RB sin 20. RB sin 20 is moving towards left. So RB sin 20 is minus. Then this force 100 sin 30. 100 sin 30 is moving towards right. So it is positive. Then 70 sin 45. It is moving towards leftward. So this is negative. So I will write all the values. Here it is 100 cos 30 minus 70 sin 45 plus HA minus RB sin 20 is equal to 0. Okay. Now calculate the value of HA.
16.42.
Okay, so therefore HA is equal to positive answer आला का?
Yes, sir.
16.42 Newton. Our direction is correct, towards right. कसा assume केली होती आपण direction towards right. So this direction is correct. HA. Now you know the value of VA. See here, you know the value of VA, you know the value of HA. So find out RA. So now resultant reaction at A, RA is equal to under root in the square root HA square plus VA square, which is equal to under root 16.42 square plus minus 96.55 square. Therefore, RA is equal to, solve this and let me know the value.
Ninety-seven point 88.
97.88 Newton. So this is the RA. Okay, this is the RA. Now we need to find out the alpha A. So alpha A is equal to tan inverse mod of VA upon HA. Therefore, alpha A is equal to tan inverse of, in mod we have to take VA upon HA. So VA will be 96.55 and HA will be 16.42. Therefore, alpha is equal to, answer, value of alpha E
80.34.
80.34 degree. Okay. Now after all of these things, finally we need to draw one diagram. Okay. So I will show it to you. For this resultant, we should show RA and alpha A angle. For this, we need to draw the diagram. So arbitrarily, I am taking one point here. Okay, this is my point A. Now see here, at point A, VA. What is the value of VA? 96.55. But VA is moving downward. VA is moving downward. So I will show the VA which is moving downward. So this is the VA. As it is moving downward, there is no need to write the minus. We have already shown it as a downward. Newton. Then from the same point A, HA is also there and it is 16.42 towards right. It is moving towards right. So I will draw 16.42. This is HA. This is HA, which is equal to 16.42 Newton. Now I will complete the parallelogram. Okay, if I complete this rectangle, I will extend this. Then the diagonal of this from point A up to here, this is my resultant. This is RA. This is RA. Whatever the RA, you can write over there. And this angle with horizontal is alpha. This angle with the horizontal is alpha. This is the resultant diagram. And we have already calculated the value of RA and the value of alpha A. Okay. Is it clear? समजला का problem?
Yes, sir.
मुवमेंटचे इक्वेशन इथे दाखवलंय बघा. ह्या मुवमेंटच्या इक्वेशन मध्ये समेशन एम मध्ये काय अडचण आहे का अजून? Do you have any difficulty in this moment equation? Whatever we have applied, moment at A equal to 0. Have you understood the equation? Or anybody is having any doubt? काय problem आहे त्याच्यात?
No, sir.
No, sir.
ओके. हे 30 न्यूटन मीटर आणि 50 न्यूटन मीटर हे जर समजलं का? Those are moments. That is why we just see the direction of the moment. मुवमेंटला कधीच डिस्टन्सने मल्टिप्लाय करायचं नाही, हे कायमचं डोक्यात ठेवा. फोर्स असेल तरच आपण त्याला डिस्टन्सने मल्टिप्लाय करतो. अँड फोर्स मल्टिप्लाय बाय डिस्टन्स, दॅट इज परपेंडिक्युलर डिस्टन्स, इज नथिंग बट मोमेंट. सो फोर्स इंटू डिस्टन्स केलं की तुम्हाला मोमेंट मिळते. पण डायरेक्टली जर मोमेंटच दिलेलं आहे तुम्हाला, म्हणजे ते करून दिलेलं आहे ना ऑलरेडी, फोर्स इंटू परपेंडिक्युलर डिस्टन्स. सो देर इज, एक्झाम मध्ये अशा मिस्टेक होते की मुवमेंटला परत मल्टिप्लाय करता तुम्ही. तुम्हाला कन्फ्युज करायसाठी, टू कन्फ्यूज यू, व्हॉट दे विल डू इन द एक्झाम, the distance of this moment, the distance of this moment, it is also given in the exam sometimes, so that you will get confused and you will multiply that 30 or 50 by the distance and your problem will become wrong. Okay, so keep in this mind. Okay, when the moment is there, there is no need to multiply the moment, and this moment, externally applied moment, only you should consider in the summation m equation. Summation m stands for sum of the moments, so moment should be considered in the moments equation. Once you move out of moments equation, see in the summation fy, I have not considered there these moments, because these are not the force. Summation fy means what? Forces parallel to y-axis, but this is not the force. Okay, and in the summation fx also this will not come because it is not a force. So that things you should remember. Okay, so now if there is no doubt, then I will take the attendance. Just a minute. So today is 11th Feb. Okay, roll number 1,
Present.
2,
Present, sir.
3,
Present, sir.
4,
Present, sir.
5.
Present, sir.
Okay, 6 is present. Network issue. Okay. 7,
Present.
8,
Present, sir.
9,
Present, sir.
10,
Present, sir.
11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present.
17,
Present, sir.
18. Roll number 18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34. Roll number 34, 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present.
41,
Present.
42, 43,
Present, sir.
44, 45, roll number 40, 46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58, 59,
Present, sir.
60,
Present.
61.
Present.
Okay, so I will call the absent roll number once again. If you are roll numbers amongst this roll number, then you can tell me. Absent roll numbers are roll number 18, roll number 34, 42, 44, and 45. These are the roll numbers.
Sir, 34 present, sir.
34 is present. Okay. Anybody else from these numbers? 18, 42, 44, 45. Okay, so you can leave the lecture now.